I'm Charlie Crisafulli, a research ecologist with the U.S. Forest Service Pacific Northwest Research Station in Olympia, Washington. I've worked for the station for about 20 years, and I've been working on Mount St. Helens for coming up on 30 years. Mount St. Helens erupted at 8:32 on May 18, 1980. It was an unbelievable example of nature's raw energy being unleashed across the landscape and into the atmosphere. The heat associated with the blast started melting glaciers, causing mud flows to go down the sides of the volcanoes, inundating valleys and scouring out vegetation in its path. Tremendous amounts of pumice and ash were being pushed up into the atmosphere and then carried aloft on the prevailing winds off to the north and east, and depositing and blanketing the surrounding landscape for hundreds of miles with various amounts of volcanic material we refer to as tephra. When we arrived to Mount St. Helens, and I went out into this landscape that bared no resemblance to an old-growth forest, which had been there before, I was awestruck by what I had seen and the absence of trees, the absence of almost all vegetation. In 1982, when we were back to the site doing another reconnaissance for any type of life that might be out there, we were flying at the time, and we looked down and we saw what appeared to be a plant, so we swung the chopper around and walked up, and sure enough, it was a tiny lupin plant, a prairie lupin, in fact. So what we did is decided to put a plot around this plant and track the fate of this individual to see what would become of what, as far as we knew, was the single first colonizer on the Pumice Plain. Elk, like the rest of the large mammals at Mount St. Helens within the areas influenced by the lateral blast, perished instantly, and so all of the mountain goats, the black bear, deer, and puma perished immediately. But the elk were very resilient, so they bounced back relatively quickly. And this was in large part because of the vegetation that resprouted, many species such as fireweed and various grasses. And these are very palatable preferred forage by the elk. The Mount St. Helens area prior to the eruption had a great diversity of small and mid-sized mammals, and we were particularly interested in small mammals. Also, we were specifically looking for the activity of the northern pocket gopher, because this is an animal that lives beneath the ground, and so we had hypothesized that if one small mammal would have survived, it would likely be the northern pocket gopher. And sure enough, in many locations, the northern pocket gopher had indeed survived. The northern pocket gopher is a very interesting small mammal in that it's fossorial, meaning it lives beneath the ground, and everywhere it goes, for the most part, it has to dig its way there. That's what's so important. The gopher, in the process of its burrowing, mixes nutrient-rich old forest soil with the nutrient-impoverished volcanic ash and puts it on the surface by having now this topography of the mound on the surface. Wind-blowing seeds that are coming across the landscape are more apt to get trapped. The other interesting fact about the northern pocket gopher is that over the decades since the eruption, it's created a complex network of tunnel systems. And what we've seen is as elk walk across the landscape, they collapse these tunnels, creating an access route into the gopher burrows. And what we've seen is a wonderful interrelationship between gophers, elk, and amphibians, because now amphibians that are metamorphosing from the wetlands and ponds and dispersing out onto the terrestrial landscape looking for a forest, and there's none to be found, they'll often find these gopher tunnels, and they'll take refuge in these in between dry spells. Spirit Lake prior to the eruption was a crystal clear, ice-cold gem of the Mount St. Helens area. That changed suddenly on the morning of May 18th, 1980, when the landslide caused by the failure of the north face of the volcano slid into the lake, displacing all of the water. And when this huge wave went up onto the adjacent basin's walls, it brought down with it the former forest that was on those valley walls, and in fact scoured those valley walls right down to bedrock. So now, nearly 30 years later, there's still legacies of the 1980 eruption, such as the enormous log mat that still remains afloat on the lake surface. When we arrived to Mount St. Helens, one of our expectations were that of all the different vertebrate groups, The group to be hit hardest by the eruption would be amphibians because they're thought to be very sensitive to environmental change and stressors. And we were absolutely shocked when we found 12 of the 15 species indigenous to the Southwest Washington Cascades had actually survived in the area influenced by the lateral blast. Another large surprise was the fact that the northwestern salamander was found in most of the waters we studied. Even the brand newly created ponds, some 135 ponds were created, a five-fold increase over the number of ponds that were in the landscape before the eruption. So Mount St. Helens actually created amphibian habitat as well as eliminating it or reducing it. I've been at Mount St. Helens for 30 years now, and I can honestly say that I do not get bored. I mean, it absolutely shaped my life, my world. I mean, I was a 22-year-old kid when the mountain erupted. So what more could an aspiring young ecologist ask for than to have a mountain erupt and have the good fortune to be able to work at Mount St. Helens and spend your career there? From my perspective, I would be elated to see another eruption. Of course, I'm concerned about loss of life and property. But that aside, we are now poised through 30 years of research to really evaluate the responses of an eruption to the suite of organisms and ecological systems around Mount St. Helens. So it would be a great learning opportunity if we were fortunate enough to have another eruption during my career.